Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from y of x, y, z, x square plus y square plus z square equal to 0 by eliminating phi, which is an arbitrary function. We are given a relation and we are asked to form a partial differential equation by eliminating this phi. So here we can solve in three ways. First thing is, we can write if we consider this as u and this as v, you can write u equal to f of v or v equal to f of u, or you can use the determinant equal to 0, determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0. So here in this video we are going to see using u equal to f of v, and also I'll show you the answer using v equal to f of u, and we'll see this in the next video. Okay, fine. Given phi of x, y, z, x square plus y square plus z square equal to 0, consider as equation number 1. Now we rewrite 1 as x, y, z equal to f of x square plus y square plus z square, u equal to f of v. Consider as equation number 2. Here f is the arbitrary function. Okay, phi is the arbitrary function in the given equation, and we have rewritten it to u equal to f of v form, and here f will be the arbitrary function. Now let's partially differentiate it with respect to x. Partially differentiating with respect to x. Since we are partially differentiating with respect to x, so we'll treat y as constant, right? Just apply dou by dou x on both sides of 2, or do directly since y is treated as constant here, I will write it as y into dou by dou x of xz. Okay, equal to partial derivative of f of x square plus y square plus z square is f dash of x square plus y square plus z square into dou by dou x of x square plus y square in a derivative. This gives us, here we are going to apply u v whole prime formula. We know that u v whole prime equal to u prime v plus v prime u, right? This gives us y into z into dou by dou x of x plus x into dou by dou x of z equal to f dash of x square plus y square plus z square into partial derivative of x square with respect to x is 2x plus partial derivative of y square with respect to x is 0 plus partial derivative of z square with respect to x is 2z into dou z by dou x. Since we have a notation dou z by dou x equal to p, we'll just replace dou z by dou x using notation p. This gives us y times z into partial derivative of x with respect to x is 1 plus x into dou z by dou x equal to f dash of x square plus y square plus z square into 2x plus 2zp, since dou z by dou x equal to p. Right? Fine. This gives us y times z plus x into, we can replace it by p, you'll get xp equal to f dash of x square plus y square plus z square into, we'll take 2 common here, you'll get 2 times x plus zp, right? Or you can write this as yz plus xyp equal to f dash of x square plus y square plus z square into 2 times x plus zp. Consider as some equation number 3. Now let's partially differentiate 2 with respect to y. Partially differentiating 2 with respect to y. Just apply dou by dou y on both sides of 2. Since we are partially differentiating with respect to y, so we'll treat x as constant and we can write this as x into partial derivative of yz. Partial derivative of f of x square plus y square plus z square with respect to y is f dash of x square plus y square plus z square into inner derivative dou by dou y of x square plus y square plus z square. Here we are going to apply uv whole prime formula. We'll get z into dou by dou y of y plus y into dou by dou y of z equal to f dash of x square plus y square plus z square into inner derivative partial derivative of x square with respect to y is 0 plus partial derivative of y square with respect to y is 2y plus partial derivative of z square with respect to y is 2z into dou z by dou y. Since we have a notation dou z by dou y equal to q, we can replace dou z by dou y by q. This gives us x times z into partial derivative of y with respect to y is 1 plus y into dou z by dou y equal to f dash of x square plus y square plus z square into 2y plus 2z into replace dou z by dou y by q, right? This gives us x times z into 1z plus y into, you can replace it by q, you'll get yq here equal to f dash of x square plus y square plus z square. Take 2 common, you'll get 2 times y plus zq, or you can write this as xz plus xyq equal to f dash of x square plus y square plus z square 2 times y plus zq, right? Consider it as equation number 4. We have equation 4, that is xz plus xyq equal to f dash of x square plus y square plus z square into 2 times y plus zq, right? Now observe equation 3 and 4. Using 3 by 4 we can eliminate f dash, right? Now using 3 by 4 we'll get LHS of 3 by LHS of 4, RHS of 3 by RHS of 4, where f dash and 2 gets cancelled, and this results to now make a cross multiplication and simplify it. It's q, okay? This gives us y square z plus yz square q plus xy square p plus xyz pq equal to x into xz, x square z plus x into xy cube. x square yq plus zp into xz square p zp into xyq xyzpq xyzpq gets cancelled. Now write the terms that involves p and q in LHS part and the terms that does not involve p and q in the RHS part. Already we have these two terms here which involves p and q. Let's write it down and bring this term and this term to LHS. You'll get minus x square yq minus xz square p equal to, here we have a term which does not involve p and q, so write it in the RHS part. Take this to RHS, it becomes minus y square z. Now take p common from these two terms and q common from these two, okay? Or you can just take xp common from these two terms, right? Let's take xp common and see what we are going to get. Y square minus z square. Now take yq common from these two terms, you'll get plus yq times z square minus x square equal to, take z common, you'll get x square minus y square into z, which is the required partial differential equation. Or if you write in the same pattern y square minus z square, here we are having y square minus z square, here you can write it as x square minus z square by just taking minus outside the brackets, okay? Or you can write this as xp times or p times y square minus z square into x minus q times, I'm just taking this out, so I'll get x square minus z square, right? See, minus x square, you'll get minus x square, minus into minus plus z square, you'll get the same thing into this y equal to x square minus y square into z, which is the required partial differential equation. Now let's see, using x square plus y square plus z square equal to f of x, y, z, that is when v equal to f of u. If this is our equation 2, if we rewrite equation 1 as v equal to f of u, what happens? First we'll partially differentiate. Yeah, I said I'll show you, but I'm not going to solve. I'll just write it down. Okay, this is how we get using v equal to f of v. So p times y square minus z square into x minus q times x square minus z square into y equal to x minus y square into z is the required partial differential equation. Is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.